Welcome to the Radical Hospitality Show. I'm your host, Zeke Freeman. Today, we've got the pleasure of speaking with Tim Alatorre, who is a licensed architect and really a visionary in space habitation design. Tim is the CEO of Above, which is the world's largest scale construction and development company. They have this ambitious aim to make space accessible for all, with plans for a luxury space hotel and other business type operations that will really be just taking place here in the next few years. So, Tim, it's an honor to have you on the show.
Zeke, it's good to be here. I think I was on the show or a show with you years ago, so it's nice to be back. We've done a lot since we last talked.
We've had the kind of fun pleasure of getting to know each other a little bit on the traditional architecture side, and part of a mastermind group, and learned a lot from each other. So I am really excited today to kind of dive into some of your new ventures, relatively new ventures. I know you've been at this for a little bit. So you run a traditional architecture company, maybe since what, 2012, something like that?
Yeah, 2011, 2012, in that time frame. Yeah, that's Doma Architecture, located in Northern California, just east of Sacramento. And we do all the traditional things, multifamily, single family, commercial, light industrial, restaurants, bars, axe throwing, which is really popular right now. So I joke that I've built terrestrial structures, all over the place, all shapes and sizes and types. And so not that that's boring, but the next adventure really is in space. And so
that's from straight there. So over the past 5 years, I've been hearing you talk about transitioning to this space design. How did you get involved in this, and how did this come about?
I say terrestrial architecture. Which, talking to, licensed architects, people always chuckle about that, because having to make that distinction of terrestrial versus non-terrestrial is kind of a new thing. But the terrestrial architecture side and all the myriad of projects that Domum does is really what opened this doorway into doing what I'm doing now with Above Space Development Corporation. Voyager was this flagship station concept that we started back in, I think it started in 2018. I got involved about end of 2018, 2019. Dr. Tom Spilker, he's the one who initially came up with this concept for Voyager, the high-level structure and layout. He's good at keeping people from blowing up. We joke that that's his job. My job is to keep people from throwing up, both from just a physiological standpoint, but also an aesthetic standpoint. So I got roped in because of Domum and the work we were doing with Domum to initially just consult and just provide some insight. And so Domum was hired on a contract basis. And at that point, it was really just a kind of a theoretical project. But as we started getting into this, we started thinking, okay, well, what are the barriers to actually making this a real project? And Zeke, I know we talked about a fun project you're doing, a development project, right? Where you've got like this vision for a project. And so first you need the place to build it, right? You need the land. You need a great design and a concept, something that people are going to want to use. You need the technology, the components for it, and then you need the funding for it, right? And we've talked a bit about the funding part on your projects. And so looking at space development, well, there's plenty of space. There's no shortage of real estate off planet. It literally is infinite, right? From a technology standpoint, NASA's been doing this for the first kind of people in space were back in the 60s, right? The first habitats in the 70s, late 60s. We know how to keep people alive in space. There's no technology development needed. And so then the cost piece of it. Back in the 60s up until about 10 years ago, the cost to get 1 kilogram of payload to orbit was around $8,000. It peaked during the shuttle era up into this, like $60,000. Now with SpaceX and reusability, we're down $2,500 a kilogram. So the cost to do this is now within the realm where you don't have to be a government. You don't have to have the backing of one of the major superpowers. You can do this with commercial funding. And so then the only other piece was the will to do it, someone to pull it together. And so that's where in 2019 we incorporated. We initially, it was called Orbital Assembly Corporation, because we saw ourselves as just building the station, in orbit. What we learned since then over the last 5 years, there's not enough end users to fill a hotel yet, right? The cost for a ticket, like if you wanted to go down and stay at an Airbnb, I don't know, 2 hours away, you drive over there, you make your reservation online, you pay you a couple $100, $700, you got a great weekend away. The ticket price to get to space is still in the tens of millions of dollars, 50 plus million. The number of people who can stay in a space hotel is still relatively small. And so what we actually rebranded about 2 years ago. We're now above Space Development Corporation because we're really looking more at the whole ecosystem, not just how do we get tourists to space, but how do we build up all the support structure to get the space economy to the point where we can get ticket prices down in the tens of thousands of dollars. The goal is at some point in the future, you look up, you're going to see our stuff.
What's driving this space development? Like what's changed that, makes this the time to do this?
I think the real sea change, the paradigm shift happened about 5 years ago also. There's this crazy South African guy who said, I'm tired of space not being this exciting thing. We've kind of gotten in this rut. I want to do something ambitious to get people excited about space again, get more funding for NASA. He went to Russia to see if he could buy an ICBM to launch a plant in a little greenhouse to Mars. Turned out that wasn't possible. He decided to start a rocket company to bring down the cost of rockets to get people excited about space. Of course, I'm talking about Elon Musk, right? Nobody thought what he was doing would succeed. He almost didn't. But now, all these years later, the whole space industry has been turned on its head. Like I mentioned about the launch costs, that's come down. We're more than 50% less in cost than we were just 10 years ago. And that price keeps falling. The number of launches, like SpaceX is doing each year, the number of launches that most companies have done in their entire existence. The volume of payload going to space and the price for that payload is at an unprecedented level right now, right? Cost is low, volume is high. And we're seeing other companies now building off of that growing market. So there's companies like Rocket Lab. They're a company in New Zealand. Blue Origin, who they're about to finally go orbital, hopefully in the next couple of weeks. And there's a bunch of other ones. Like there's just a rocket launch out of Japan yesterday. They failed, but they're trying. There's innovative companies like Spin Launch who are trying to get stuff to space at a really low cost. If you think about if you wanted to build, again, a hotel, let's say you wanted to build one in downtown Cincinnati, just throwing it out, right? Like, the cost of materials, the cost of shipping of those materials is marginal. You don't really think about the shipping costs as being the primary driver for building that building. But in space right now, the shipping cost is the primary driver. And so getting that cost down means that we can now start to look at more participation in space, larger structures in space. And then that coupled with a shift towards NASA being a customer of commercial space as opposed to being the provider of all things space. So that mind shift started in the Obama era. First Trump term, it really accelerated. It's kind of been on kind of simmer mode during the Biden administration. The last 4 years, there hasn't been a lot of excitement in the current administration with space. But now with Trump coming back in and Elon being, really tight in there, we're expecting that this next 4 years will be another big boost in commercial space. And so with NASA shifting from doing everything in-house to hiring commercial companies to do things, that's also another big shift to where companies like ours and a whole host of others, there's a customer, costs are reasonable. It's just an exciting time.
You mentioned Blue Origin. Now, my very first project as an intern when I went to Lake Flato Architects was working with Jeff Bezos on this big ranch that he had purchased out in West Texas. And the only thing that was out there, it felt like the moon. We went and walked the project and, there's a little ranch and, he had this vision and I thought, man, this guy is insane, but he's going to change the world. We just helped him kind of initiate like our little renovation for a base camp. And then to see, Musk, kind of took off a little bit after that. And this energy just seems to be, really brewing. It feels like you kind of step back to even JFK's, time where he says, hey, we choose to do these. We go to the moon, not because it's easy, but because it's hard and it'll bring out the best in us. And so having some of our, some of the wealthiest people kind of lean into that still and doing what you're doing, I think really is opening up doors into a challenging space.
Well, and what we're seeing isn't unprecedented either. So we saw this back in the 1800s where commercial industry came in with assistance from the government and, breaking down regulation, barriers to entry, the railroads, right? If you think about the explosion of the railroads in the 1800s, what that did for industry, for commerce, for the economy, it was, unparalleled to that point. And then in the 1900s, you saw the same thing again with, people like Henry Ford and others who came in and revolutionized automobile manufacturing and the automobile, trucking, right? Another huge change in transportation and the movement of goods.
The idea that an individual might own a car at a time where everyone's riding around on horses, it's just unfathomable. The thought of owning a personal computer now is in your hand. And I think you guys are on the cusp of, we're not there yet, but as it's moving forward, what you keep talking about and this cost coming down, this accessibility.
Maybe the car is not the right metaphor there. Maybe aviation, because that was another big transportation change, right? Like you and I don't own trains. I don't own a plane. Maybe you do, Zeke. I don't know. You're very successful. But most people don't own a plane. But the advent of rail and air travel completely changed commerce. I think the automobile did as well, trucking in particular. And so I think that's what we're going to see here, where you and I probably aren't going to own our own rocket, but having access to being able to move goods and services and eventually people freely between Earth's surface and orbit, eventually the moon, Mars, asteroids. When the American West was unlocked with the Transcontinental Railroad, think about all the resources that were unlocked that completely transformed the economy. The amount of resources in space, it's hard to comprehend. The numbers get so big, like we just can't comprehend it. And so when you start unlocking not only mineral resources and physical resources, but also the energy in space, microgravity, is a massive resource that people don't really consider for manufacturing products. Once we make that accessible to everybody, the quality of life, the wealth, the quality of life for everybody is gonna change in ways we just can't imagine right now.
And where do you see we are in this spectrum of things in terms of that becoming the automobile versus us being on horses? Do you see, like right now, is this still? Obviously, if it's tens of millions to get into space at the moment, there is people that could do that. I don't know how large that is, and it doesn't need to be enormous. But will you be serving that crowd in this first development? How soon does that happen? What do you see the stages to where it becomes more accessible?
Yeah, it's hard to match that milestone for milestone with vehicle transport like automobiles and planes, but there's different levels of access. So right now with Above Space, our goal are these bigger stations. We're trying to get companies in industry ready to use those big stations, but there's not, nobody wants to lease 10,000 square feet in space yet. We have these stepping stone projects. We have a smaller station called Pioneer, and then we have a free-flying platform called Prometheus, which is, there's two versions of that. One is like the size of your desk. The other one's the size of a room, basically. And then we have our missions that we're doing to the International Space Station. So we just completed a mission to the International Space Station. That payload had been up in space for about 7 months. It just splashed down 2 days ago. There's another mission that's up there right now. There's another one that's integration that's going to be launching in February. Another one in October of next year. The barrier to entry for that, companies can participate for thousands of dollars, single-digit thousands. Well, we're trying to get these companies ready. So if you think about hospitality right now, right? If you're looking at opening a hotel, the major systems like the structure, the HVAC systems, electrical systems, those NASA already figured out. That's not a problem. But the catering for the food service or what cleaning products you're using in the hotel, there's so many little things where those are problems NASA hasn't solved. So we have companies, for example, that are flying seeds to do testing on how to grow vegetables in space so people can eat those. We got companies that are doing research in advanced solar panels to increase the amount of power available in space for doing manufacturing. We've got companies that are doing research on specialized coatings. And so right now we're doing small scale that will then move to larger prototypes and then eventually full scale manufacturing.
All kind of underneath this goal of the Voyager as a space hotel. So there's components that you're having to kind of work through.
When we got into this, again, there's for the hotel itself, there's no real barrier to entry other than funding. But in order to fund it, we need all these other companies to be ready to do their part. And so it's a lot of baby steps, hand holding, really just educating people on what's possible. Any company who wants to right now can start to do operations in space, develop product lines, develop manufacturing processes. Just give me a call. We'll figure it out. Like there's no reason that you couldn't work in space. And for the last 60 years, companies have think, well, I need permission from NASA. I need to apply to NASA. I need to get the green light from NASA. That barrier to entry doesn't exist anymore.
Anybody can go to space. There's really not. I got to get a permit or regulation.
Well, I mean, there's still permits for certain things, but it's not like you have to ask permission. The permits are more for like, are you launching a weapon system? Are you, are you using communication channels that are authorized? FCC and stuff like that.
But you have to have a big enough vision and why to drive people to get out there. So talk to me a little bit about this hotel. What will it be like when you're inside of this? What are some of the design considerations that you put into this? What would the experience at a hotel in space differ from like the International Space Station? Different considerations between what we've already have up there.
Well, I'm not sure, Zeke, if you've ever been to a laboratory, like a working laboratory. Or a hospital. Everyone's been to a hospital. If you imagine going to a hospital, let's say like the surgery center or something like that, that's basically the International Space Station, right? Like it's not a great vacation spot. It's a laboratory. It's a research facility. It's engineering focused. It was designed to keep people alive, not really to keep people happy. It's a stinky, miserable, dirty place. Astronauts are excited to go there because they're in space, and that's just, an awesome thing. But when you're looking at a tourist destination and wanting people to go there to relax and to have a good time, that is not the place. And so in designing a hotel for space and designing something where people want to go and want to spend time there, we really went back to kind of, zero-based design, basic human needs, basic understanding of human physiology, color, space, volume, just really breaking it down. In the station that we're planning here, well, there's two stations, right? There's the Pioneer Station, which is envisioned as being a microgravity station that can then convert to artificial gravity. Voyager is designed to be artificial gravity from the get-go, which means it's rotating. And based on physics, size and all of that, and just what we understand that humans can tolerate, the stations will be rotating about 1.5 RPM. So it's just slightly faster than the second hand on an analog clock. And that'll give us about 1/6 Earth gravity, which is about equivalent to the moon. So we see it as a training facility for astronauts and people that are working on the moon. Also technology, they can test it on our station. That level of gravity also dramatically increases human comfort. You can now stand. You put something on a table and it stays put. On the space station, you could just drop this pencil and it just floats there. In 1/6 G, it's gonna kind of go down and it'll set on the table. You can have liquids staying in a glass. You can have food staying on a plate. There's just all these things, that minor little comforts that we take for granted here on Earth. And we also, working with Dr. Ronquillo Lebisi from UC Irvine and Dr. Mae Jemison, who's a former NASA astronaut, they assisted us in putting together a very comprehensive report on the effects of microgravity and artificial gravity. We're hopeful that with this level of artificial gravity, it will also decrease the health effects of being in microgravity. Our bodies are not designed for 0G. We evolved here on Earth and we're designed for Earth. So there's a lot of cognitive, vision, sinus issues that come with being in a low gravity environment, microgravity, zero gravity in particular. So with 1/6 G, we hope we'll be able to mitigate some of that. And that also means there's some fun opportunities. So I'm not sure how athletic you are, Zeke. I can't jump that high. I don't know. On a good day, maybe a foot, just a straight vertical jump. But in space, in a 1/6 G environment, I could jump 6 feet. So there's a whole lot of fun kind of sports opportunities there. We plan to have, a module dedicated for recreation and sports applications. And then because we have that the low gravity, the 1/6 G, we'll have, restaurant and bar, actual food as opposed to the stuff in tubes that astronauts have to eat right now. And then, there's all these interesting things with rotation where you end up with Coriolis effects, particularly in the inner ear. And so as we've designed like the sleeping accommodations, orientation of the bed, orientation of seating, just making sure that when people are getting up, sitting down, they're moving in a plane that won't cause them dizziness, and it's in line with, minimizing those Coriolis effects.
Like when I think of the space station, I usually think of like tubes and people kind of flying through a relatively crammed kind of space. What is the scale and the size of these things and the pods? Like,
so we have a mock-up of the central core of one of our modules for Pioneer that's under construction in our facility here. The central core is kind of what you're thinking about. It's more of a, it's about 2 meters by 2 meters. And that's, you can think of it as like the hallway. So Starship, which is SpaceX's, new big platform they've been testing, has a much larger payload fairing. Typical payload fairings like the Falcon 9, Delta, they have about a 5-meter diameter fairing. The International Space Station was designed, that size was designed to the largest size they could fit within the space shuttle. I think that's about 1.4 meters. Let me just check. Yeah, it's about 4.2 meters. The Falcon 9 is about 5 meters, so a little bit bigger.
Or are these components that you then put together and kind of assemble in space?
Well, so that's the thing, right? So with the space station, everything was sent up intact as a module, and then you connected these modules together. And so those modules are limited to that 4-meter roughly diameter. Once you can start to assemble or deploy structures in space, then you can go much bigger. So, and there's a lot of really innovative concepts out there, not just from our company, but others. We're looking very heavily right now at inflatables. So CR Space has been doing a lot of work with that. There's some other companies that we're working with that have been doing a lot of work. Bigelow Space did a lot of work about 10 years ago. They have a module on the space station right now called the Beam module. And what that allows, inflatables allow you to have that central core. Let's say you had a 5-meter fairing. You got that central core that's about 2 meters. That's a rigid structure potentially. And then around that, you have your soft goods, which are deflated. And so you can pack a lot into that extra meter that's, outside your central core. And then once you're on orbit, you inflate that and it gets much bigger.
Would that be canvas type walls in space, or you still have a shell component?
So there's lots of different types of textiles, right? Like Kevlar vest, right? That's a textile. There's a lot of things trying to kill you in space. One's the vacuum of space. So you have a couple of different pressure, linings that contain the gas. Then you have structural restraint systems. Then you have what's called, MMOD shielding, which is the orbital debris shielding. And that can be anywhere from, the rigid aluminum modules, that shielding is about 10 centimeters thick, up to maybe like 15 centimeters. For the inflatables, because we're using textiles, that could be up to, a meter thick, potentially. So you have a bunch of shielding just to make sure that, small debris doesn't poke holes in your vessel. Now, one thing, people think about, well, what happens if something hits you and it pops, right? And you think about like a balloon popping, or even worse, last year there was that catastrophic failure of a submarine, right? Where it just completely collapsed in on itself. Thankfully, in space, you can have quite a few leaks and be okay. Like the space station is constantly leaking. There's all sorts of holes in the space station, and nobody's died yet. As long as you replenish that gas faster than, you're losing it, you're good. And so, but we are looking at methodologies in case of a catastrophic depressurization to where you still have your structure and it's safe. Safety is number one concern.
How large of a diameter of spaces do you, in maybe feet, are we talking about?
So for Voyager, we're looking at a diameter of about 12 meters, 39, 40 feet. So we're in that range. Pioneer, which would be smaller, will also, be large enough that we can have multiple levels. So like each module will be a multi-story building.
When we think of a building, we're also thinking about a tube here, is how I'm envisioning it.
Yeah, with like a rigid structure, well, you could do a torus with an inflatable, but the way the pressure is working, like a sphere is kind of your optimal shape, but there's other oblique kind of elliptical shapes at work, like pill shapes, where you kind of have a cylinder with round ends. Torus is another nice shape. You're looking for those stable shapes. For our modules, we're looking at more of a pill shape, where you have a cylinder and then spherical end caps.
And those get kind of joined together.
And then you join those together. Yeah. So you could, and again, from a safety standpoint, if you think about like in a large terrestrial structure, you have fire separation, right? You have allowable areas where you don't want to have a space so big that you can't evacuate the people from it in case of a fire. And so you split up your space based on occupancy and you want to have safe egress. So one of the reasons for keeping these stations as kind of separate modules is for safety and for egress. And that's one of the calculations I did was, okay, in an emergency situation, can we get the occupants from one module to another module in a reasonable amount of time to where there's no danger to those occupants, basically.
And then is there kind of a central corridor that connects each of the modules?
Yep.
Around?
Central corridors, elevator shafts to move people between the different sections. And one question we get a lot also is, how do you dock and undock a spacecraft from a rotating structure? And so Voyager and Pioneer both have non-spinning sections. So they're stationary relative to the planar surface of the Earth, to where a spacecraft with people or cargo can come up and dock to that. I'm not sure if you watched 2001: A Space Odyssey, but in that movie, there's a space plane coming up to the Space Hotel, which is a Hilton hotel, and that spacecraft starts to rotate to match the rotation of the station, and then it flies into this bay.
I was just thinking that, like, how much precedence. I mean, Hollywood's been doing research on this stuff for us for years with Star Wars and multiple movies. Like, how much usefulness have you looked at, what Hollywood has come up with and said, oh, that's worth taking?
Yeah, I've looked at it more for like kind of being aware of where the public consciousness is, of like what people think is futuristic, what we don't want to do. There's a lot of bad examples in space as well. We're not going for the Star Wars aesthetic. But to my point with docking, so if I have this, right, this in rotation is not stable rotating along the long axis. There's this effect that happens where it starts to want to wobble and then eventually just flips around. It's no good. It wants to rotate kind of in this direction. And so if you think about a rocket approaching the station, it would take a tremendous amount of fuel and some complex algorithms to be able to rotate it like this to then dock to the station. And so just to reduce that complexity, it's easier just to have a portion of the station that's not spinning, and then the rocket can just come up and dock. And so like in that case, Stanley Kubrick, way ahead of his time with 2001: A Space Odyssey, but they didn't quite understand the physics. When that movie was made, people had not spent time in space. I think we'd done some suborbital flights. Maybe somebody had orbited the Earth once, but it was way ahead of his time. Oh, I think Interstellar, they got a lot of the physics right on rotation. Their scale was not quite right, but the concept was good. 2001: A Space Odyssey also, they had the scale wrong on rotation. Just for filming and Hollywood's sake, they show it as 1G, on those rotating sections. They have to be a lot bigger or spinning a lot faster to get 1G. So I know there's some things that work, some things that translate. Like The Martian, there's some cool things in that movie about how they assemble the different structures. Like anything in architecture and design, you look at everything that's out there and you get inspired by it.
We all try to start with art designs that way. Sometimes it's, film, sometimes it's, inspiration images. And I think, taking from what's already come before is an important thing to do. Let me fit a little bit to Prometheus.
We are moving forward with that.
Why Prometheus? This is Prometheus, kind of a Greek Titan god. What's behind the name of it?
Well, do you know what Prometheus was famous for or infamous for? Like what his great sin was?
There's something about stealing fire, right?
Yeah. He stole fire from the gods and brought it to mankind. And so Prometheus is above's step to basically steal the resources from space and bring it to humanity. We're designing it to be really an egalitarian platform where anybody can do something in space. And it's that stepping stone, it's that spark. In fact, our very first platform is called Prometheus Spark. It's the spark that's going to ignite this flame of pushing humanity into space. Prometheus is an automated platform. There won't be people on it, but we're going to be validating and testing all the major control systems, algorithms that will lead to these larger platforms and stations, and also helping our customers validate their hardware and their systems that can eventually be used in larger platforms. It's an exciting program. We're raising funds for it right now. We've got several customers signed and under contract. There's some customers that are just doing it for PR, like they want to be able to fly their company brand and their logo, and we'll take pictures of it in space and, hey, we're in space. There's some that are doing more humanitarian work where they're taking things to space because it has some significance. And then there's others that are doing technology demonstrations, like solar panels, propulsion systems, control systems that can then have applications in different markets. So it's a wide range. I'd mentioned like on the International Space Station, there's a company, Shipshape Urban Farms. We flew seeds for them to space. They're interested in using space, well, in the future, growing plants and food for people living in space. But right now they're using space as a test bed to develop new seed varieties that have better yields for Earth applications. So plants that grow better in dry environments, for example.
When you say you flew then to space, do you guys also have the rocket components as part of above? Because we've talked a lot about like the space hotel that you're building and Prometheus as a module of that. What about getting there? Is that
we're the service provider and the platform? We use a different trucking company. In the case of all of our ISS missions, that's all flown by SpaceX. Yeah.
Okay, so you're kind of partnered with SpaceX to get there.
I mean, it's really broad. We have, like in a mastermind group, we talk about our, ideal clients and our niches. There's a couple of different niches, right? So there's the marketing niche where, like I said, companies that want that brand exposure of doing something interesting in space, right? Toll House Cookies, they sponsored a cookie baking experiment on the International Space Station, cooking cookies in space. It was a PR stunt for them, some marginal scientific value. Anything you do on the International Space Station has to have some scientific value. Prometheus, we don't care about science. I mean, we do, but you don't have to have science, right? So there's that. That's one category. Another category is technology validation. So there's a lot of satellite platforms and space applications that are nascent and growing, and companies are developing really cool things with different satellite propulsion, control. Data center. That's data on space. That's another huge market and niche. So that's another thing we're looking to fly on this first Prometheus mission is a micro data center. Data processing on orbit, Bitcoin mining in space. I mean, there's all sorts of things that you can do with data. And then the last category would be kind of that sentimental piece. So right now, actually, you can go on our website or shop.abovespace.com, something like that. But you can fly a picture to space. So, if you've got a family portrait, we'll fly that to space for you and you can get it back and you can have something that, put on your wall, like, hey, my family went to space, or picture of your pet, or even your pet's ashes. Like there's these kind of like human connection pieces that we're doing as well.
And so if we go onto the website, we could, and I wanted to send up my grandfather's ashes, I could do that on board, your ship going up.
Yeah. And for that piece, because there's human remains involved, we have a partner company, Celestis. They handle all that piece. Celestis is our customer in that sense, and so you would go through them, and then they put it, they get it to us, and we put it on the vehicle.
And then once I'm up there, then Prometheus itself is what is that? Is it a module?
Yeah, so there's two different versions of Prometheus. The first one, as I mentioned, is Spark, and then we have what we're calling Prometheus 1. Spark's much smaller, and Spark is designed really to be a rapidly deliverable platform where we can send up a lot of them at a time. Like I said, it's about the size of a desk. And Prometheus 1 is much bigger. So they're automated. There's no people on board. We can provide pressurized vessels. I mean, for this first flight, I think everything is going to be in the vacuum of space. Nobody's doing anything with the atmosphere. We were on a call yesterday with a customer they're working on a mission that will have an atmosphere, but I think they're probably about a year out from being ready for that.
And then you said you're raising capital for it. So what is the investment component?
Yeah, so you can go to invest.above.space and invest right now. We have a lot of interest from the Department of Defense. We've completed 2 contracts with the Air Force through Air Force Research Labs. There's this piece in military development where the Defense Department has funding for initial kind of prototyping, and then they have funding for the actual contract. But there's this valley of death in between there where you got to go from the prototype to the actual product. And so the investment right now is helping us bridge that gap to where there's interest in the Department of Defense with our Prometheus platform for a variety of applications. We have another platform we haven't talked about called Archimedes, which is really a power and communications platform. And we developed Archimedes because doing large-scale manufacturing in space, you need a lot of energy. That was a spin-off of trying to get enough energy for these metallurgy and forging applications in space. So the investment is to help us get to that point where we can get those government contracts and really get the cash flow funding. Once, the big piece we haven't talked about here is money. A Voyager station is going to cost a lot of money, and we're not expecting a government or a billionaire to come in and fund the thing. We want to be able to cash flow it through commercial enterprise. So the International Space Station missions, those are profitable. Those are helping to fund Prometheus. Prometheus will help us fund Pioneer. Pioneer will help us fund Voyager. And we have a very clear commercial roadmap where we can cash flow each of those steps. And so the investment is really helping to us accelerate that. So instead of doing it in a decade, we can hopefully do it in less.
I want to kind of step back to, do you mind if we go a little bit weird? On the Prometheus, I think it's interesting. I don't know if you read any of Tim Alberino's Birthright. He talks a little bit about, kind of this idea of the gods, Prometheus not only stealing fire, but he, brought knowledge back down to Earth. And just being in this whole component of space exploration, what are your thoughts on like the golden age that some of the gods in the past connected space, imparted knowledge on humanity? There's a lot of that going on. Do you see any of that having any basis or for what we're exploring these days?
Yeah, absolutely. NASA did a study where they track every dollar that's spent on the space station and the impact of that. And they did a study that showed that for every dollar invested in space fundamental research, there was a 40x return economically for commercial terrestrial applications. And so we anticipate that to continue. We've learned a lot over the past 20 years on the International Space Station, and that's been there's a heavy gatekeepers to operate in the International Space Station. Once we open those floodgates to allow any company to do research and development in space for any reason, yeah, I think not just the 40x economic return, but the knowledge return is going to be significant. Like space has impacted us in so many ways we just take for granted. Basic kind of things like mapping and the GPS on our phones, but then CT scans, CAT scans, Velcro, semiconductors, solar panels. There's so many things medicines. I mean, there's so many things we take for granted that we use every single day that were developed because of or as a spinoff from research and development done in space. We just have this first mission that's coming back from the International Space Station, just splashed down 2 days ago. There's some research on there, in particular, some of this plant research that ship's doing that could have significant impact down the road. We don't know yet because we haven't analyzed the results. I think it's inevitable. I don't have a specific case study yet. Give me 10 years and I'll have a list. It's exciting to be a part of it.
What do you see is next for above?
So we've been doing a lot of planning and strategy and realignment. Domum's going to grow. We're hiring some new people. Job listings are coming out soon. And, we're just wanting to continue to grow that brand. And that Domum is Latin for, it's like an action. We're doing something to your home. And so Domum's all about making places feel more like home, whether it's a restaurant, bar, office, or your actual home, just making it feel more like home. We want to spread that vision. So we're growing, we're hiring. We want to, I think 2025 is going to be a great year for terrestrial architecture and development. For above, Prometheus is the big focus this year. As I mentioned, we have 2 missions to the International Space Station coming up this year. We haven't talked about this, but we have a partnership agreement with NASA, and I'm located here in Huntsville, Alabama. We do a lot of work with Marshall Space Flight Center. And so there's a lot of interesting things that we hope to be doing with NASA this coming year. One of the exciting things is we're looking to set up our Mission Operations Center at the ISS Mission Operations Center here at Marshall. And that will be for Prometheus and Pioneer and Voyager. So that'll be exciting. And then just a lot of testing, vacuum chambers, flat floor, thermal testing, EMF testing. So anytime I get to go and hang out with NASA engineers, that's a good day. And so there's should be a lot of that this year. And then, just opening up space to more people. As a kid, I wanted to be a part of space. There really wasn't a way to do that. As of today, right now, December 19th, 2024, Above has a way for anybody who wants to participate in space in some capacity. I think our low point of entry right now is like $64. You can participate up to, millions of dollars, but there's a entry point there for everybody to participate in space in some way. And I think, for us to have gotten to that point in just the last 5 years is pretty exciting. So we're going to grow that, more opportunities, more ways to participate.
I can't wait to see how, you guys continue to take that same, hospitality approach of making spaces feel more like home, and how you begin to make space feel more like home. I think you're going to have a great impact. If people want to get in touch, be involved in this next step in space, what would be the best place for people to get in contact with you or see some of the work that you're doing, Tim?
So above.space is our main website. Invest.above.space is where you can learn about how you can invest in the company and the opportunities there. And then shop.abovespace.com. I'm realizing we should make that shop.above.space so everything's consistent. But shop.abovespace.com is where you can go and participate today, sending a picture to space. Also, if you go there in the next couple weeks, we're going to have some cool things that flew to space that we're getting back that we're going to be selling. So if you want something that flew to space, we'll be having that available as well.
Very cool. Very cool. Well, Tim, I appreciate you taking the time, share some of your wisdom for what you guys are doing out in space and all of your input. I just, I'll be keeping an eye on what you guys are doing out there. So thanks for joining us on the Hospitality Podcast.
Yeah, and we talked big picture today. We didn't even get into like HVAC and electrical systems and like the logistics of running a hotel in space. We'll have to touch on that another day.
Absolutely. All right. Appreciate it, Tim.